In this video, I am gonna demonstrate about the discharge summary agent. So we are given the medical report of a patient. I have picked up the 3 pages out of it. So what we have to do is that agent come to the hospital and it got discharged. So it is a report of it of all like what problem it had come with. What are the issues they had, what the medicines it took, what the medication changed and all, and when it got discharged, what difference came to its basically routine and all. That is all the medical records are written over there, written by nurse, and also what the surgeon does that all took all the records which in the PDF format and uh, in the PDF format and which are handwritten notes, which I have already shown you here. You can see, yeah, this one. So these are there are more pages in this, but I have just took it for the demonstration purpose because I will tell you right now. So it took up the PDF and parses. So so it took up the PDF and it runs the agent and it gives back the summary what actually happened over the course of the after the patient got admitted. Okay, and it got discharged. So what actually changed during that course of that time? All those things we not uh, we the agent will summarize using the records. So how this is going on, so let's understand the internal. So it take up the PDF. So for PDF we know machines don't understand handwriting, okay, or even text. So we will take up the PDF and we would parse it. I am using PDF parser, so it would uh, if it's digital if it's a digital record, then it would easily parse all the text and everything. But if it's a handwritten one, it can't like it can't do anything about it, right? So what we will do, we will divide every one. First, we will divide every pages of the PDF. Like if there are 100 of pages, so we will divide each page into parts and then we will parse one by one every page, or we can batch it. It depends on what depends on performance or what we are gonna see. Actually, I will tell you later. Here you will here it will make sense when it's needed. Okay, we can do that. So suppose there we have one page and we wanna parse it, it will easily parse if it's a digital one. But if it's a PDF one, then it will delegate data, it will pass that to the OCR. Like I can't do this one, so can you do that for me? So OCR will come into the picture. So I am using here the Tesseract. Tesseract is the good one if you wanna run it on the local. I am exploring what are the other options too, like TCOCR by Microsoft, but I haven't set up that up. I have used the Tesseract, which has worked pretty much well. I have also generated the reports. I will show you in the last, I think that would be. So yeah, it will go here and it will it will what actually in the OCR, optical character recognition. So it will guess what it is written. Most of the time it guesses wrong, not most of the time, tries to be it tries their best to get get what actually is written, but I can we can see here that it has messed up their work. It hasn't done their work really well, but yeah, what we can do about it? Nothing, right? So instead of that, we can also use the AI parsers. Like there are Google Vision or but we had to make a lot of LLM calls, right? Or there must be some other option. I need to explore that. So we can optimize on that. In the next step, we are also using the we are calling the LLM. So basically, it's gonna 2x the calls. So basically, I have removed that one, the Google Vision one. So the LLM call. So cost become 50%. Yeah. And so after we have got the text, we have stored it in an array. We we can usually what the agents do, we stores it in we embeds it and we stores in a vector data. But here is no need to do that. It's like we are gonna um, perform multiple operation like multiple reports. I have there is an agent. I will give this agent patient of one report. It will give the summary of that one. Then it will take it in a big hospital. There are thousands of patients, so it will perform like thousands of operations. So we want to have a as minimum cost as possible, and as less LLM calls we make, that would be better, and we want faster results. So yeah, taking all those in care, I have choose the tools very wisely. Okay, I may not be that much wise enough because I haven't explored that much, but try my best. Okay, so and later one after we have got this all of the texts. After this, I have got all of the um, uh, all the text of the every pages, and we have stored it in the format like I have collected this text from this page. Like we are storing the source of the text. Okay, so yeah, in a structure format. Why we are keeping it? Because we want, why we are storing, because it will help in making our agent efficient. Otherwise it will hallucinate us. So yeah, and LLM could, we don't want to give the LLM anything like it would help us in giving the LLM in the final call when we are summarizing. We want it summarize it better. We don't want it. I want who is doctor? Then he will say potato is a doctor. We don't want it to invent anything, right? So for that purpose, we are gonna uh, do all these things. Okay, so after we have got all this, we are gonna pass it to the LLMs. Like we are gonna start making calls either by batching, or we can do if our input amount number of inputs are very low, then we can directly pass it to the one by one to the Gemini, or I am using here Gemini 3.5, the latest one. You can use any one cloud or chat GPT, grok, whatever you wanna use it for the summarization. It's not a very big task, anyone can do that. Okay, so it would it check it. So what we are doing in this phase is that we are taking that text and we are converting it in a very structured format in the like in a diagnosis. Here we will have diagnosis. I can show you that too. Very, yeah, this is the format we are gonna we are asking the AI to give our. So this is the page and it will give in this format, like this was the source of text and the fact is this, like what the diagnosis we have got. So and the medication, this is the name, dosage and frequency and all. We want it in this format. Okay, so after that, yeah, this one is our evidence. This is how we were storing when we got it from the OCR. Like this is the page number, this is the source tag what I have got, this is the fact. So like this. Okay, so yeah, where I was, yeah, after I have got all the summaries from basically, or not all the so after we have got all this text in this format. So we will start storing it in somewhere, right? We will start storing it in some local storage. We can use whatever local storage. I am using the array directly because it we are not gonna use it like for regularly, right? So we are just putting it in a state variable. We are using it as a state variable. So I will put everything in a state variable, or I can call it like state variable, because this is what we are gonna uh, come back to again and again while the all the loop is running. So we have stored the evidence, or whatever you can say, the text, actually the generated text, which has the source of truth uh, added to it in their JSON. Okay, so after this we have got the agent. What the agent is still, actually we have got the state, right? Do I have, yeah, I can show you. Yeah, so this is, we have got the state. Can I show you? Yeah, I can show you from here the state loop. Okay, state, where it is, output, ingestion, extraction, evidence extractor. Yeah, you can see this. We are putting all this what we have got. This we have got the output from the model in this format, and then we are gonna put in our state one by one, refining what that why don't we did it in the make the Gemini to directly put the say in a array. Why it will just it's not, that's not how it works. It's just gonna output a single file, right? It's not gonna output a multiple files at once. It could do, although it's not like it can't do it. Gives back a JSON. You can see that but we want to put that in a very structured format. We want to add something like that. You can see here. So this is why, what is evidence? Evidence is the type, their schema type, TypeScript. Let's not talk about that. Let's stay here. Okay, so after this we have got the state variables. Now yeah, but before parsing that we are gonna but while parsing all this information, while passing this information, I forgot to tell you that we need to follow some rules, that if we directly give this one to the so it is gonna make lots of mistakes, right? So here is the, so have you found the fact? So the array, if found any fact, like you have the dialysis, so it will found a source. Do you have source? Then it will store the source. If not able to found any source, then it will escalate, it will mark for the review. And if, so let's talk about it in the later class. We are gonna do this again in the loop, right? So I can also show you the prompt I am sending. If it's, yeah, you can see this one opportunity you are gonna, yeah, you can see unknown is greater than never fabricate, means you are not going to make anything or of yours and never guess. So basically I am so this is, so I am passing it in the prompt, but it is not going to do anything. Like it's not a very obedient one, that I say to do something and it starts to act in that way, right? So we are uh, so we need to make sure we are passing it the correct one. So all those things we have already, so before passing the pages, we have already done all the things. Where is the OCR? OCR. Okay, ingestion. Yeah, OCR. You can see here. Update pages. Apply OCR fallback. Yeah, it will update the pages. Apply OCR to page. You can try this one. Yeah, this is the format. You can see. Okay, anyways, let's move forward. Let's we come back to the loop. Okay, so now we will observe. We will observe, does it need any reconciliation? Means, does there are two types of, like, first, in the first page it's saying you have diabetes. In the fifth page it's saying you have hypertension. So these two conflicts. So yeah, this is reconciliation, I think. Mm, yeah, I think. Yeah, this was it. Um, yeah, reconciliation maybe. Why something different? Yeah, the admit and discharge when. Yeah, so the difference, basically, someone was taking 2 minutes. So basically, reconciliation is the difference it made between the patient got admitted and it got discharged. Okay, so that was. And the conflict detection, like, one page is saying something and the other page is saying something. That one is. And validation, uh, does it need anything else? Is everything valid? The validation is this one. Found fact, you have found something, like, suppose, you blood pressure was 100 milligram, or you have a very high BP. So does it have any source? Does it any have any source? We had stored all the in the state variable, right? So does it have any source? If yes, then store the evidence that yeah, it has source. Yeah, verified. If not, exclamation mark for the review. If it if some fact is not found, like, we were searching for the allergies, we are, but allergies not found, then we will mark that this person we haven't found the allergy. We are not gonna mark that this person has not allergy. We are not the doctor. We are not making a agent doctor. We are just making a obedient agent. Okay. So, we will do some. We don't want any hallucination. This is all kind of hallucination. What is the hallucination? It is basically the superpower of the agents to make up very different types of many result which don't even exist ever. Like, we haven't said it to these. We haven't told it about the facts and start to inventing many facts, and. Yeah, all that. And fun fact, and is there any conflict? If there is a conflict, then it will flag conflict. Yeah, and if there the result pending in some of the reports, like, this person's blood sugar test is pending. So yeah, so it will just mark for pending. It's not like. No, we are done. We are. So what real doctors do sometimes, it says, yeah, yeah, it's all done, all done. Yeah, we are gonna earn money. Yes, but it's a agent. We don't want all those results. We want a reliable one. Yeah, and uncertain. So there are some fact we are uncertain. We are uncertain about some things, like, we don't actually how much medicine we have to take, like dosage we are not able to found anywhere, like, or we found sometimes like 250, or like, about this uncertainty, right? If in such cases we will escalate, like, we will prompt all these wherever I am marking for review. Basically, all these points, all these pointers, all these things which are marked for review or for conflict, all these will be prompted to the user or doctor or whatever whoever is using that agent. Okay, so he will uh, clear all those conflicts, validate all those things manually. After that, after all the validation has passed, we are gonna only then we are gonna put it in the send it to the LLM. Okay, send it to the LLM so that the final summary could be generated. We will make that final call. Yeah, we will pass the state finally with the prompt that we you generate prompt. Yeah, that one. Okay, and this and in this loop, whenever we are doing something like, yeah, all these are called updating variables. So we will be updating variables, and also we are tracing their source. We are keeping all these what all are the steps have done, is it even done, are everything validated? If no, then agent loop will go, and you know that it's a loop, so it can go infinite number of times. We don't want that. We have limited amount of money. Suppose, of course, it's related to money, right? What if we are gonna consume a lot of tokens, but you know, we are not actually making any LLM call over here, right? Are we? Are we making any LLM call? Can you tell me? Can you tell me? Are we making any LLM call? Not really. No, we are not making LLM call. If the design was that for we have done all those things already. We are not going to do it again and again. Yeah. So everything depends on this initial state variables. We want it to be really strong one. Okay. After that, this one is the very important one. After this, we need to, so we will limit this one, like go for 30 times, 40 times. We don't want to waste our resources, right, for that purpose only. So we are limiting this agent, and on the other side also we don't want to go in like if someone is using our app in their phone, if it keeps on going running and running, then the phone will hang, it will keep on consuming their RAM, and phone will hang. Then it's a very bad user experience. Don't want that, right? So yeah, that was it. I think let's see the safety guardrails and all agent. I have already talked about all this fabrication and everything. Let's see if I have missed anything. Yeah, safety principles. No, no, nothing. All done. I don't think anything left here. Yeah, conflicts occur. No fabrication. Trace logging. Tracking. Evidence extraction will convert call per page, but when were we stopping? When we store that, we would ask the doctor what's wrong. Yeah, I think this is it. So let's move to the demo one. I can't show you the demo right now because it takes time when I click enter. So that's why I can show you actually, but yeah, let's leave that. I have just created it here. If you can see the time, you will definitely realize that too. Here is the summary. You can see the discharge summary. This all this medication, discharge medication, dosage frequency. It's in the same format we wanted to keep it. Yeah, you can see dosage one tab, everything. Similarly, review flags what we have found, the ambiguous, all the ambiguities are here. This is our superpower, and the guardians we have put in the guardians here. Okay, so these are the, like, how many, 19 flags, yeah. But and you can also see that some of our why not needed really, like you can see there, IV fluents was missing for missing for medication, yeah. So some of the typos are also like which do that, like if there is something like a medication, medication, so it got that too, but we don't want to interfere with that. In market there comes some medicines like medication and medication, so yeah, we don't want to tamper with that. We don't have any authority to decide who would rename their company's medicine name to what. Someone is saying it's Cipla and someone is saying Dolo. It's their wish. They can say whatever they want. Okay, so this was the execution. The loop, basically trace of the loop. Loop started, plan creator, reconcile, detect conflict, validate. It's the same. Evaluating step 1, reconcile, step 1 completed successfully. Executing step 2, detect conflict, step yeah, all the validation is over here. Yeah, and along with it I have also got all the logs in the terminal. Okay, so yeah, I think this is it. I have also some of the test cases over here. Integration test 2. Yeah, this is it, I think. Should I? Yeah, so basically we have give the PDF. Let's give a brief summary of this. So we will provide the PDF. PDF will go through. If it's a digital one, then it will be passed very easily, basically the text. And if it's not the digital one, the scanned one, then we will use some great tools. Whatever we want, that tool, the OCR or Tesseract OCR, TR OCR, or anything, vision models, which are best, which are used mostly right now. Okay, and then it will be passed to the LLM Gemini to do all this hunting. Okay, what should I? No more hunting actually. Actually, to do their to extract the text, right? To put it in a very structured format, then evidence store, it will be stored somewhere, then it basically state variable will be created, it not the Gemini one, but we will be created it manually with our own hands, not in our hands, by the programmatically. Okay, so and then it will be passed to the loop, and then everything will happen as we have already told you. It will check all the validation tests, all reconciliation, does there any change, difference and all, then conflict detection, if and all those things, and yeah, fabrication and all. We don't, so we will be putting guardrails over there. So yeah, this is it. Thank you for watching. Yeah.